Hi guys, welcome to this video on how to deploy Python Flask app to serverless ECS environment using Jenkins. Here's the high-level deployment plan. I'm trying to simulate how it's done in a work environment. So basically, there is a developer machine. The developer develops his Flask app on the developer machine and then pushes the code to GitHub. There is another machine that hosts Jenkins. The DevOps engineer would clone the repository, create an image from the image of the app from the repository, and then push that image to ECR. ECR is the Docker equivalent on the AWS, and the DevOps engineer would then create containers from the image that's stored in the ECR and deploy it to ECS clusters. ECS is the serverless. ECS has a serverless option. If you go with ECS Fargate, we don't have to manage the instances. AWS takes care of it. So that's the high-level plan. So basically, you would need a AWS free tier account, and you would also need a GitHub account to successfully replicate this this deployment on your side. So as for the software that is needed, you would need an SSH client tool on your machine like Mobaxstorm or PuTTY or WinSCP to access the Jenkins or the developer machines that we create on the Ubuntu. And for the developer machine, I'm using a EC2 Ubuntu. We would need to install Python as we are developing Python Flask app. I would need a Git client to push the code to the Git repository. I would also need a Docker as I want to create a Docker container, a Docker image container, and test it from the developer machine. We would need Git account with a Git repository. As for the Jenkins machine, again, it's hosted on a DevOps EC2 Ubuntu instance. We would need to install Jenkins on the Ubuntu machine, and Java is a prerequisite to install Jenkins. And in addition to Jenkins, we also need Docker because we would use Docker client to pull push the repository, create an image and push it to the ECR repository. And obviously we need ECR repository to store the image on the AWS, and the ECS cluster is our target deployment environment. Now let's go on to we need to access the AWS management console first, and from there, we would create the EC2 instances. So let's go to the EC2 dashboard. Here, we would need to create an EC2 instance. First, let's create a developer machine. So launch instances. So let's look for Ubuntu, UB, Ubuntu. So I'm going with Ubuntu 18.04 instance. Let's select this. And then I'll be mostly using the free tier account. A note of caution here, there might be a minimal charge for some of the resources we use, particularly the ECR and ECS. For now, I'm going to be using T2 micro instance for this developer machine. Okay, in here we need to choose let's see the number of instances, one VPC. Let's leave it to the default. And if you see this auto assign public IP, we need to enable that so that we have an IP that we can access from the laptop or our client machine. So this is all that we need here. Rest of them, let's leave it to default. Add storage up to 8 GB, it's free, and if you anything on top, it's there might be a minimal charge. So let's add tags. I'm not going to add any tags as of now. Now let's review and launch. Okay, let's do security groups. comes with the default secure. It creates a new security groups. It has SSH connection. Let's add one more um, rule here, because we would be accessing this instance over the internet. So we need to add HTTP or port 8080, and it need to be accessible from the internet. So review and launch. Okay, here you can either create a new key pair, or okay, let's create a new key pair. Okay, now this is going to be called ECS key pair. Okay. That's going to be the instance. Download key pair, the EC2 instance. So now we have created an EC2 instance. If we go back to the EC2 dashboard, you can see there is a instance that's getting created. Let's call this as the developer machine. DEVE. Okay, so this is our developer machine. The next thing that we have to do is access this developer machine from Mobaxstorm or any client tool, and then configure it, and do the installs that is needed to create the Python Flask app. Now let's log into the developer machine and install the required software. If you see here on the developer machine, we need Python, Git client, and Docker. So I'm going to log into Mobaxstorm, which is my SSH client tool. You could use PuTTY or WinSCP also. Here we need to copy the public IP from the instance developer machine. That's the public IP, and put it here. Specify username. The default username is for Ubuntu servers or Ubuntu, UBUNT Ubuntu. On the advanced SSH setting, we need to use private key. You need to keep the private key safe, because once it's lost, you won't be able to retrieve it. I have my private key here. Click OK. Now it's connected to that SSH server. If it does not connect, you might want to check your inbound rules on the security group. It needs to have a HTTP rule. Now first thing you do is sudo to the root user, so you are able to install all the software that is needed. First we want to get all the updates that's available for this Ubuntu server. So sudo apt-get update. So this is going to get all the updates that's needed for this machine. We have to remember all these scripts, because these scripts would go into the Docker file we create for automation purposes. And after we install the updates available for this machine, I'm going to install Python. So sudo apt-get install the -y. We just say yes for all things. So I'm going to install Python 3. Okay, Python is installed. We also need to install Python 3 virtual environment. These libraries are needed to create virtual environment for our projects. Okay, I'll put all this scripts and commands as an attachment to this YouTube video. Now we have installed Python. We would need to um, check if we have Git on this machine. Git. Okay, we do seem to have Git here. So if I run Git command, it shows that Git is available. And let me see if Docker is available on this machine. If you type Docker, okay, now it says Docker is not there. So we can actually install Docker by running this command, sudo apt install. Now Docker is installed here. Now we can check if there is okay, if you do that, you'll see the Docker version. Now we want to create the actual Flask app. So before that, let's make a directory here where we want to Flask app. Okay, cd Flask app. Now we are going to create a virtual environment in this within this folder. So when we deploy the application, the whole virtual environment would get deployed, and now we need to create a virtual environment for the app. So I'll be running these commands to create a virtual environment. Sudo virtual environment. Python 3, we need to specify it's Python 3. You might have Python 2 also on your machine, but you want to use Python 3. And it's going to create a new folder, env. Okay, and now I need to run this command to create the virtual environment. Sudo python 3 -m my app. So it's creating the virtual environment. If you see, it creates a folder called my app. That's a virtual environment folder. We have to activate this virtual environment. So this is a command to activate source my app / bin /act activate. So the virtual environment is activated. Now you can see this virtual environment here. So we need to create the app itself now. So I'm going to vi app.py. I'll create a script file here, and that's going to be a simple Flask app that will display the contents on a browser. So we would need to import Flask libraries. Flask. The Flask library may not be installed, but when we run it, we'll find out. If needed, we could always install it. Import Flask app equal to Flask dot Flask name dash dash. The Flask provides a library that gives the route to your HTML pages. So this is the option dash methods that you can use on this app. This is actually a API. Methods equal to, for now we'll just keep get Okay, we will define this is a function that returns the home page. It's really a simple one line here. Return. I'm going to put some HTML tagged text here. Each one. My first Jenkins Docker. Okay, let's see. ECR ECS serverless ECS deployment. Okay, that is that /h1. This is the HTML tag text. This will display as a browser, as a web page on the browser. So we have this. Now we want to execute the functions from this Python module. So we have to put this name is equal to main here. We're checking if the name is main, then we run the script from this file. Main -- colon. Now we will specify the port number on host and port number on which it runs. We will put debug go to true. Let's run this in debug mode. Host. Look, it should be localhost 0.0.0.0.0 colon. So that's the app. It's simply going to display this text on this localhost page. Okay, now my app is ready. Let's run this. Python 3 app.py. We need to remember this all the scripts so we can put into the Docker file and Jenkins pipelines when needed. Okay, line 10. Invalid syntax. There is some syntax error. Let's see. app.py. Oh, this need to be a colon. Insert. Okay. This need to be a colon and escape. PQ. Okay, now we get an error that's called module not found error. No module named Flask, so we don't have Flask libraries. So the way we do install it is pip 3 install flask Flask. So this is installing the Flask libraries. Let's try running the app.py again. So okay, now it's just started the app.py on the developer EC2 instance. The way to check this, we need to get the IP address. So we'll go here, copy the IP address, go to your browser. Okay, and paste it there. And the port number is 5000. Now I'm trying to connect to that app. It's not actually connecting because I think I need to open up port 5000. So I'm going to do that now. I'm going to go to instances. Now go to security. And I need to edit the one of the inbound rules and add port 5000 as open for the application. So I'm going to do that now. Edit inbound rules. Here I'm going to add another rule to allow traffic on port 5000. This is port 5000 from the internet. Okay, now I should be able to access the app on port 5000. If I try this now, okay, there you go. Now I'm able to access the app from on port 5000, but I ran this app directly on the Ubuntu machine. I want to containerize it and run it. So I'm going to create a Docker file. The Docker file would go in the same location as your app. So I'm going to do vi Docker file. On the Docker file, we need to put all the commands that was run to create this the virtual environment and all the installs that were done on this machine. So I'm going to do that now. So basically we can start with Docker file starts with an existing image. So I'm going to be doing something like an existing image of Ubuntu. Insert from in uppercase. This should be, the keywords must be in uppercase here on the Docker file. From Ubuntu. We ran some commands to get the system updated and install Python. So I'm going to capture those commands here. Run apt-get upd update -y. I'm specifying y so that it doesn't go in interactive mode. I'm going to run one more command. So that's going to be apt-get install -y Python 3 dash the package installer for Python. I'm going to run one more command to install virtual environment. That's going to be apt-get install Python 3-venv. This, we need this so that we are able to create virtual environments. I need to do all the I installed Flask as part of getting the application running. I want to capture all those custom installs in a requirements file and copy it over. Actually, I haven't done that, so I'll do that after creating the Docker file. But the command to copy the requirement file is this: copy /req. They should be in lowercase. Requirements.txt into app/requirements.txt. Okay. And the work directory is going to be, these are all keywords in Docker and need to be in cap. Now we need to, whatever requirements we need to install on the target environment. So run pip install -r requirements.txt. That's going to install all the requirements. Copy all the contents files and folders from the current location to the working directory on the target machine. The entry point is going to be this is the first command that is going to run once it logs into the creates a remote machine after all the installs. So we are going to be running Python 3 colons. And the command that it needs to run is cmd it's going to be app.py. app.py. Okay. This needs to be in quotes. Okay, that's all that is needed for the Docker file from Ubuntu. That it's going to start with an Ubuntu image and get all updates for the Ubuntu machine that's available. It's going to install Python 3 web. It's also going to install the virtual environment, and we are copying all the requirements from the current machine to the target machine as part of the Docker image. The work directory is app, and we are installing all the requirements. And entry point is Python 3. It's going to run app.py on the target machine. So this is all that's needed on the Docker file. I'm going to save the Docker file, try running it. Before that, I have specified requirements file in the Docker file. I need to I did not capture that before creating it. I'm going to create it now. Pip freeze. Requirements.txt. Pip freeze requirements.txt. Now, if you see that file is created and we are all set to create a Docker image and Docker container, I'm going to check if Docker is available here. So it is there. If not, it will show a command to install the Docker that can be done. Now, to create a Docker image, I'm going to run this command, docker build -t, docker build -t. I need to give an image name. I'm going to call as my app, or let me see. I'm going to call my image as my app. Docker build -t, everything that's from here. So it's building the image now. From the Docker file. The build failed if the error message. I know what's the issue with the build file. With this, we have to remove any of this libraries where the version is 0.0 or not available. We can check the requirements file. I had some issue with this libraries where the version number is 0, so I'm removing those libraries. From the requirements file, I'm removing those libraries where the version number is 0. Now I'm going to create the image by running this command sudo docker build -t dash. Okay, now it seems to have created the image successfully. I can check Docker images. And if you see, this is the image and the tag as the latest. And so the image is created successfully. Now this image is a clean image, so I can create a container from this. And let's go back to the router and check. Now we stopped that Python app, so we are not accessing this. Now I'm going to create a container that will run the Python app and access the Python app from the container. So that will be Docker run -p. Let's do the port mapping between the host and the container. To keep it simple, I'm mapping from port 5000 to 5000. And here we have to give either we can give image ID or use the repository name colon the tag. So let's do the I want to use the repository name because we want to put a name on the Docker file or the pipeline script that we can find out from the repository name and tag latest. That's Docker run -p port mapping 5000 to 5000, and this is the image identifier, like which is repository name colon the tag. So this should give me this should create me a container that runs the app. So now it created a container that's running the app. Now we can go back to that. See, now this app is running from the container. So far we have successfully created the developer machine. Basically, if you see, go back to, if we created this developer machine, install whatever software is needed and create the Python app. And we were able to run the Python app on a container and see it on the browser. Now we have to push this code that it's like, to simulate a work environment, developer would push that code to GitHub repository, including the Docker file that he created, so that whoever is building the pipeline can use the Docker file and deploy it to ECS. So that's going to be the next step. I need to create the GitHub repository first. So let's go to that next. Now we can create a GitHub repository. It's available for free. If you go to Google and do free GitHub repository, you'll see that GitHub homepage, and sign up and enter a email ID that you have access to. I'm going to be creating a password. Now we can continue with creating the GitHub repository, GitHub account. I'll go with the student account, which is like a free account. Check all those that apply. Okay, now I've created a free account, so I can log into continue for free. Okay. Okay, this is the new GitHub account I created. Now I can create a repository here. I'm going to call it as Py App Flask, and I'm going to make it a private repository and create repository. Now, as soon as you create the repository here, it gives you the commands to uh, to push code into the repository, and we are going to be pushing code from a folder. So we would need to do a git init and then run this first set of commands to push code from the Ubuntu into the Git repository. Going back to the Ubuntu machine, this is the developer machine. So now we have to be in the project directory where we created the Python app. So I'm making sure I'm there. And if you see, this is where we have the virtual environment folder, my app. And if you see the Docker file here, and this should be exactly the same location from you start pushing your code into the Git repository. So I'll start running the commands that I got from the GitHub. All we have to do is run this as it is. That'll add the code we want. I'm going to be running a git init command. This registers all the files and folders that is here in this location of the GitHub, so that it creates it starts tracking these files and folders at this location. So now if you see, it says initialized empty repository, and then we will add whatever all the files and folders from this location. That will be git add dot here represents all the files and folders at this location. So we are going to add all this to the thing. So it starts it puts the files and folders in a queue with the Git engine. Now we can check the Git status to see if all these files and folders are being tracked. If you see, all these files and folders are being tracked. These are the ones we created for our virtual environment. And we need to commit git. This will add all these files and folders into the local repository. Git commit Py app Now all the files and folders have been committed to local. Now we have to add the remote repository, GitHub repository, as one of the origins. See if, and then push all these files and folders into the remote repository. To do that, I'm going to be adding the remote. All I have to do is copy out the command from here and run it there. Git remote add origin, it adds the remote repository as one of the target repositories to this location. So now that is been added. Now all I have to do is run a git push to the remote repository. And this command pushes all the files and folders into the remote repository. And here origin here represents the repository, remote repository, and main is the branch where we are going to deploy the code. Okay. Now it seems we don't have the branch main, so we need to add a branch. I missed a command from that list. So basically, if you see, I need to run this command. So I'm going to run this now. And if I go back and run, this asks for the username. Before that, in order to push this command, you need to generate a password. It's called the personal access token. So we can do that from the GitHub. So let's go back here on the repositories. You should go to we should go to the settings under the profile here. If we go there, there's settings here, and once you click on that, on the left pane, you would see something like a developer setting. Okay, on the developer settings here, you can click on personal access tokens. This is kind of the token that is used to log in from the remote machine to this GitHub. So generate new token. I'm going to these are just nodes. Say access GitHub. Okay, I'm choosing 30-day expiration or maybe no expiration, and I would choose all that applies because we want to ensure that that the personal access token is able to access GitHub and do all these functions. So this is a token. We can copy this and save it to be used while accessing the Git repository. Okay, now going back to the console here, I need to enter my name, the user ID. That's my user ID. Here, instead of password, we need to enter the personal access token, which is I right clicked and it already took the personal access token. If you see now, it started the deployment of the remote repository. If we go back to the remote repository here, now, and if you go to go in here, repositories. Now, if you see, we already have this inside the PyApp Flask. Now, all the files and folders have been copied into this folder, including the virtual and environment folder. So now, so far, we have done the first two steps in the whole flow. We created the Python app here, tested by creating a container, and we have, deployed, copied or pushed all the files and folders into the GitHub. Now we have to create this Jenkins EC2 machine that's going to clone all the repository that we just created here, and then it's going to create an image. We will push the image to ECR and use that image to create this cluster. This is going to be done manually, and then we will subsequently automate the process. Now I'm going to show how to create this EC2 instance and launch it, install Jenkins on it. We have to go to Amazon console. Here, launch instance. Look for Ubuntu. Ubuntu 18. Now T2 Micro. Here, only thing we have to do is enable the public IP for AutoSend IP. Next, we grow with 8 GB for free tier. No tags. Configure security group. We need to add one for HTTP, because we'll be accessing this through the internet. For all, okay, on port 80. Review and launch. You can launch this instance. No key pair found. I'll reuse an existing key pair, or you can also create one. Or I'll create a new key pair. Okay, now that's done. Launch instance. I have my key pair here. Okay, it's launching the instance. Now the first step is done. Now we can log into that instance using the Mobax term. Okay, now sessions SSH. Okay, now we go back here, go to the instance. This is the instance. I'm going to call it the Jenkins. Here, copy the public IP, paste it here. The default user is Ubuntu. It will be Ubuntu. On the advanced SSH setting, we need to choose the key pair we are going to use. That is new Raj PM. Okay. Now we are logged into that EC2 Ubuntu machine on which we plan to install Jenkins. First things first, let's sudo this root user. Now we need to sudo install apt get updates. Always run this command as the first one, apt get update. So any updates available for this machine is applied. To install Jenkins, we need to install Java first. So I'm going to install Java. We can check if there's a Java version available. We don't have Java, so we can install Java now. I'm going to install Java 8 because Java is needed. If you guys already have a Jenkins and you don't want to install it, you can skip this section. Probably this takes about 5 minutes, so you can skip the next 5 minutes of the video. Now let's check the Java version here. we have Java 8 installed in here. Now let's go on to installing Jenkins. The first command is to get the Jenkins from the website. So that's the wget command. Here is the wget command. Okay, it ran fine. Now I'll put all these commands as an attachment to this video, so you can follow the same. Or also, you can easily find this on the internet if you go and look for how to install Jenkins on Ubuntu 18.4. The Jenkins install in progress. Actually, I followed the instructions from the official Jenkins website. If you go to Jenkins IO docs, installing on Linux, and we need to follow the instructions from this debug and Ubuntu. I'll share these links and commands to install. Now the Jenkins is installed, we can actually, we had to start the Jenkins instance. That will be sudo systemctl start Jenkins. Just like this. We can check if the processes are running using this command, Jenkins. So you can see there is two processes running. One of them is an agent, another is a Jenkins engine. Now that we know that Jenkins is running, we have to open up port 8080. Okay, so now we have to configure the Jenkins on the machine. So we have to capture a default admin password, and this is the command to do that. So we have to, this is a very, very important password. We need to save this. This is the admin password for Jenkins. We need this to configure Jenkins. Okay, now the Jenkins should be available on port 8080. Let's try that. I'll go here. I'll copy this public address. And let's check this on port 8080. I think, oh, I need to, it won't open the page because, I need to open up port 8080 from here. Go to instances, the Jenkins instance on the security group or on the security. We need to edit the inbound rules here. Inbound rules. I need to add port 8080 in here. Okay, I'll add it here. Custom TCP port 8080, open to public internet, save. Now that's been added, now we should be able to access that here. If I refresh, Okay, now the first time we log in, it's going to open up this unlock Jenkins page. We need to put that password that we captured from the Ubuntu, I mean Mobax term here. So let's copy this and paste it here. Okay, save this. I'll go with the install suggested plugins. It's configuring Jenkins for the first time. Now the Jenkins is installed. We need to create a default user ID password. I will go with Raj123. Okay, now I have the Jenkins up here. This is the Jenkins console. Now we can create a pipeline that will pull the app code from the repository. In here, we are going to create a new pipeline project. So go to new item, choose pipeline. Let's enter my app, Flask. Click OK. Now this is going to create a new pipeline project here in Jenkins. And this, all that we have to do is create a simple script it's a Groovy script to pull the code from the GitHub. So let's choose this a GitHub project, and we need to copy paste the URL from the GitHub. Go to GitHub. This is the PyApp repository. Go to code, and here you'll see that URL. Copy this, and let's go back to and paste it here. Okay, and if we go down here, if you know there is a wizard. If you click, if you go down here and if you click the pipeline syntax, it opens up the wizard that checks the syntax and generates a script and checks the syntax. And if you go in the sample step, do look for a GitHub get. So let's try this. So if you paste the URL here, and we are using the main branch, so let's choose main as the branch. Okay, now it failed authentication, so we need to use the credentials. You need to add credentials here, Jenkins. So username, for the password I will put the personal access token. Add. Okay, if you go down, you'll see it here. Add this here. So now it's able to, Jenkins is able to access this. It just tested. Otherwise, you'll see a red colored error message. Generate pipeline script. So this is the script that we need to run. copy this. Let's go back to the pipeline here. Here I have to put node. This is a declarative script, so it's to start with node, and this is all that we need to pull the code from the GitHub. Save this. Now. Okay, it succeeded. Let's see the console output. So if you see, it's able to connect to the GitHub and pull the code that we pull the repository, and it actually creates a new repo on the Jenkins machine at this location. If you see the work directory, that's where it creates the new repository on the Jenkins machine. This is where we'll be having the code. Copy. If we go to the Jenkins machine, and if we go in here and see, it has copied over all the contents from the repository, the Docker file, the app, the virtual environment folder, everything is here. Now we can build the app here, and we can create an image and then deploy the image to ECR and use the same image to run a app on ECS cluster. So far, we have developed the app in a developer Ubuntu machine, and then I pushed the code to the GitHub repository, and I also created a EC2 instance to host Jenkins, and I created the Jenkins pipeline that will pull the GitHub repository. Clone the GitHub repository into the Jenkins machine, and I also I create a Docker image from that Docker file that's there, and then create the container application here. Next, I'm going to create a EC2 repository that's going to be the Docker for us. I'll be putting the image onto the Docker ECR repository. And I'm also going to create an ECS cluster that will be the target environment for our deployment. The application will be deployed into this ECS cluster. ECS has two options. Either you can go with EC2 or ECS Fargate. ECS EC2 is we have to manage the servers. ECS Fargate is serverless, meaning Amazon takes care of maintaining the servers. So I'll be going with ECS Fargate. Now, going to the Amazon console here, look for ECR. Amazon ECR is available under ECS. So if you go to ECS, you'll see Amazon ECR repositories. Click on this. Create repository. So for my purposes, I'm going to keep it private. But you could choose anything you want. And here we have to give a repository name. I'm going to give it as PyApp. And yeah, create repository. That's it. It creates a repository. And if you click into the repository name, and it goes to this next images console. There's no images here, so we are going to put the image of the from the Jenkins machine onto this repository here. Once we put the image, you'll see the image name. But if you go up here, it says view push commands. So click on that. This will give you all the commands that you need to run to push the image from the Jenkins machine to the ECR repository. So now logging back into the Jenkins, I will go back to Jenkins machine. Now that I have created the ECR repository, I'm going to create the image on the Jenkins machine, and then push that image to ECR repository. And I logged into my Jenkins machine. And if I do Docker images, it's not there. Docker needs to be installed. And it gives the command to install the Docker. It's sudo apt install docker.io. So it's installing Docker. You need to be installed as a root user to install some of these things. Now the Docker is installed. I'm checking if there are any images. There is none. I'm going to be creating the Docker image from the app. Previously, I downloaded the repository onto this machine. If I go back to Jenkins and I can last build, if I look at the last build console output, it gives us the workspace where the package has been deployed, downloaded and installed. I can copy the directory and go into the directory. Serverless. So if you see, all the files have been downloaded. Now this is the location where the repository from the GitHub has been downloaded, and now you can see all the files are there, including the Docker file. I'm going to run the Docker create from here. Basically, it creates the image, and it's very important to run it from this location where the Docker file is located. Otherwise, it won't work. Docker run, build my -d. I'm specifying the image name, and it's actually building the image. Okay, the Docker image has been successfully created. Now I'm going to, we can go check on Docker images, and you will see there are two images. The base image is the Ubuntu base image. It takes the base image and installs other software for the Docker file, and PyApp is the image that we created. Now I can test if the application is running locally. Not using this image. That is done by running app.py is our application here. So I can run Python app. I think it's Python 3.py. If you see, it fails because it's missing Flask libraries. But if I run the image off of the container created from this image, it would run because all the libraries are present in the image. So I'm going to create the container first. So that will be using command docker run -p, because we are trying to map ports from the host to the container. To keep it simple, I'm going to make it 5,000 to 5,000 app dot here run. Here I need to specify the image ID, or I can also use the repository name colon the tag. So I'll use repository name colon tag, which is latest. You can see it here. This is the repository name and latest tag. So I'll do that. So now it's running the process on the server. I'm going to ignore this because it gives the private IP. Instead, I would use the public IP of the machine. This actually I'm doing all this on my Jenkins machine. I can use the private IP, which is here 2.3.85. So I'm going to go get it from the EC2 console. So here's that EC2 console. So this is my Jenkins machine. So you can see it's the same as this. This runs on port 5000. The Jenkins runs on port 8080. Oh, this may not work because we have to open up port 5000 on the Jenkins machine. So I'm going to do that now. If we go here, this is the Jenkins instance. Go to security group. Here I have to add one more rule to allow inbound traffic on port 5000. So I'm going to edit the security group, edit inbound rules. Okay, add one more rule. Here it's going to be 5000. Let's give it to internet. I mean, any server. Save rules. So now that's been saved. Now if you go here and refresh, it got refreshed. And if you see, it's running on a container. If I tried running it on my local machine, it failed because it did not find the Flask libraries. But if I run it off a container from the image that I created previously, it's running fine. So the Docker file and image, everything is fine. Now we can deploy this image onto the ECR repository. And we are doing this manually now, and I'm going to collect these scripts and add it into the pipeline to automate the process into the Jenkins file to automate the process. And now I killed that process. So now if I go back and check this, it's not running anymore. So the application is not running. So I can now deploy the code to the ECR. And if we go back to the ECR console, and this is where we'll be using the ECR push commands. Before that, we would need to be sure that we have the AWS installed on this machine. And I mean AWS CLI. We need AWS CLI to be installed in here to be able to run the AWS commands to push that image from the EC2 onto the ECR. And let's check if there is AWS CLI available here. AWS. Okay, we do not have it here, so it does give us the option to install the AWS sudo this this is the command to install. This is the command to install AWS CLI. Sudo apt install AWS CLI. Okay, now AWS installed. We can check the version of it here. Okay, that shows that AWS is installed. Actually, we have to do one more thing. We have to configure the AWS credentials in here for us to be able to connect from this EC2 onto that ECR. Let's try run. I'm going to try running that command and see if I'm able to push the image to the ECR. This is the first command that we see to to push the image to the repository. So I think we can run this command as is because it already contains um, all the necessary credentials and all. This is the account name and everything. The first command here is actually going to get an authentication token for the Docker client to be able to log into the ECR. And so I'm going to run. I just copied it and I'm going to run it as is without any changes to the command. See, now it shows that that is error. We need to have the credentials installed for this. In order to do that, all I need to do is run AWS configure. AWS configure. Okay. Here, it's asking for access key and secret key. We can create it from AWS console. If we go back to that here, the AWS console, I'm going to be creating that AWS credentials, access key, and secret key. In order to do that, we need to go into the IAM console. Go to users and here I need to once I'm logged into the identity and access management console, I can see there's my security credentials. If you're using a non-root user, you could go in here and choose the user, and it will give the security. You need to go into this link, and here we are going to be using access keys. So I'm going to there create new access key. Now this is going to create a new access key, and we get only one chance to see and download this file. It's so important to keep it safe. Um, Here it shows the key. So this is the key pair access key. We can copy paste it and keep it safe. Once we close this panel, we won't have access to this key. So it's important that this is safe. Also, I'm going to download the key pair. If you see it's downloaded and I'm going to close this. Once you can see the warning here. If it's once closed, we don't have access to these keys. I'm going to close it because I already have it saved. Now, all that I have to do is go into going back to my machine. Here I have to enter that key. We have two keys. One is the access key, another is the secret key. The first one is the access key. That's that. And now I'm going to enter the secret key. The region, this is, you can go to the AWS console, and here you can see, not this. This is North Virginia, US East 1. So it's US East 1. US. So I'll be typing US East 1. Okay. Now the output format, it's JSON, or I'm choosing JSON by default. So now it's created the AWS credentials, and anytime we try to connect from this machine to any of the AWS services, it's going to use the AWS credentials. I'm going to be running the first command to get token from the ECR repository. It's okay, login succeed. Now it's able to log into to the ECR repository. The next command, we can go to the same ECR page, and here, if you see the push code, this is going to build the app, the image, and actually we already built the image. So yeah, if you see, you can skip this step if your image is already built. So I already built the image, so I'm going to skip step 2. If not, we could build an image. Now I need to run this command to add a tag. So I'll copy this, and let me see PyApp latest. We want to ensure that that the image name is correct between the local and the ECR repository. Here I have PyApp latest, and there too it's PyApp latest. So we don't have image in the remote repository, so it's going to create that image. But local on the Jenkins machine, if you see Docker images, it shows PyApp latest, so I can just copy paste the same image and run it. So it copied the image into the ECR. Going back to the ECR console, this is, we just added a tag. Now we have run this Docker push command in order to put the image onto the ECR repository. As of now, we still don't have any images. So I'm going to run this command Docker push, and this is going to push the image onto the ECR repository. Okay, now it has pushed the image to the ECR repository. We can see the image here. We do have the image tag latest, and if you go in here, PyApp, and the tag is latest. So it's been the image has been uploaded to the ECR repository. So now we are going to the last part where we have to use from the Jenkins, create a ECS cluster and run the application from that image. So I'm going to be creating the ECS cluster now, and specify the image to be from that ECR repository. So if I'm going to the ECS console, Elastic Container Service, this is the equivalent of Kubernetes kind of cluster management service. ECS. Okay. Now, if I go into the ECS, I can see this getting started console. I can grow from there. Here, we may want to pay a bit attention to this diagram. So for it's going to this is first we have to define a task and container, and then on top of a service, and then there is a cluster we have to create. Now the task definition, we are just going to tell how many instances we want to run, on what port number we want to run. And services, basically, it's going to give us a domain name or URL that you can use to access this service. And cluster is basically, a number of instances and all those. So this is kind of, we go from inside to all the way. And if you go down below, they already have standard cluster definition, container definition for some of these applications. But I'm going to choose the custom configure. So container name, I'm going to give by app image. This is where we need to get the image from ECR. Here I'm going to create by app, and for the repository URL image, we need to get the image URL from the ECR. That is, I think I already did, so I'll cancel this. And ECR is available in the ECS. If you go to ECS console, and here on the repositories, this is the click on the repository name, and inside which we have the images. And if you click on the image, this is the image URI. We need to copy this. And going back to the ECS configuration here, I'm going to paste it in the image URL here. Okay. Now I'm just going to ignore this, and port mapping, I'm going to do 5000. That's where we want the ports to be mapped. And click on update. Next, if you go see, we are going to be using the Fargate. This is the serverless, meaning we don't have to worry about the servers and all. It's taken care by the AWS. The next, I will be using application load balancer. Next, I'm going to default all this. I'm going to give a cluster name, which will be PyAppC. Let's see, PyAppC. Rest of things I'm going to default it to keep it simple. Now we have configured the cluster. If you see, it shows all the things that we defined: the container, the task, the service is basically where we can define the web service. I mean, for load balance and all, and the cluster. It's all set now. If you click create, it's creating the cluster. It may take a minute or two, and now. As soon as the cluster is created, since it refers to the image on the ECR, we'll be able to see that see that the application on the browser. The cluster has been created. Now we can test it. If we go down here, the load balancer, we access the application from the load balancer domain name, DNS. If you click on that link for the load balancer, it goes into the load balancers. Click on this, or if you choose that, and if you go down here, you'll see the DNS name. Copy the DNS name. This is going to be the URL for the application, and the port number is 5000. So now we are able to see that Python app that just this one string on the browser. We have manually deployed the application to the ECR cluster. Now we have to automate the process by completing the Jenkins file we created, and then so that any changes we apply to the application from the source, any changes a developer applies to the application, the source will automatically pulled in and deployed into the ECS cluster. Now I'm going back into the Jenkins and then going to update the Jenkins file so that it's going to automate the whole deployment process. If I go to Jenkins, and this is the pipeline, and configure. So as of now, we have done. I've done only one thing. I just connect to the GitHub and pull the pull the repository, and that's only the first step. And then we have to I have to do the rest of the steps, like Docker Docker build, Docker run, and then ECS. I have to run commands to upload the image to ECR, and then I also have to run another command to ensure the ECS is getting updated after the any changes to the image in ECR. So those are some of the things I need to put inside this code, inside this pipeline script, and eventually and finally I'll also be automating this process to detect any changes in the GitHub and deploy to the ECS cluster. To start with, I'm going to add a stage here. That's going to be st stage. Call it Docker build. Here, I'm going to this is one of the reasons I did it manually, because I need to know what all scripts I need to run for the whole deployment process. The scripts are the key. Once I know the scripts, I can just start plugging into this pipeline script. Here, we need to run from a shell, so it's going to be like sh, and first things first, we need to cd to the work directory, which I had it as this. This is my work directory. I'm going to, because I know the Docker file is located here, I'm going to be running from there. That's going to be my first command, and then after that I'm going to run a Docker build. So I can actually go back to my my Ubuntu machine, I mean the Backstrom login, and copy paste the commands I ran to create the image. So this the Docker command that I ran to build. So I'm going to paste it here. So I'm going to be running all of this as super user. So I'm going to do sudo docker build. Okay, and again the next command is going. So after that, I don't have to run this. I use the Docker run for testing in local container. Once the Docker image has been built, I'm just going to log into the ECR repository. This is the command that I ran to log into the ECR repository. So I'll copy paste into the pipeline script here. Again, I'm going to be running this as the root user, so I'll put sudo in front of this. Yeah, even here it pipes the output from that login into this. The scripts are pipelined, so I'll do sudo here too. So this way we can avoid any access issues. Now, first one builds the image locally on the Jenkins machine, first command, and then this one it gets a token, logs into the ECR repository, and if you go back here, uh, now I need to tag. I'm running this command to tag the image. I'm going to keep the image name and tag the same, so that it automatically gets any updates. ECS would get any updates automatically. Sudo docker tag. Okay, so this will tag the repository. Now we have the last command is to push, so that would be this is the command I ran to push. This is the reason why I ran it manually, to collect the scripts and configurations that we would need to automate the process. Again, here it's sudo docker push. So now these are all the commands we need to run to automate the process. This is the Docker build. Here we can actually split this into stages, but I'll do, I'll run it on one stage. Docker build and deploy. Save it. Now configure. Okay, first we want to ensure that everything is correct on the script. So let's see, cd and sudo docker build AWS. So this should run and pick up the repository code from the repository, create an image, and then deploy the code to copy the image onto the ECR repository, and then I still have to add one more command. This is going to ensure that that the ECS will use the updated image. So in order to do that, I'm going to run an ECS command. Like all these commands, you can find it on AWS has a good reference, and AWS is really user friendly. They give you all the commands. They are easily accessible. We can go look for AWS ECS commands, and there is a good reference here. If you go here now, I have to update the service. That's what I'm going to be doing. So if you go in here, and it says update service. So this gives us the syntax that we would need to use, like AWS ECS update service, and then inside which you specify the cluster name and service name. And also it has we have to force deployment so that it accepts any changes to the image. So so that's what I'm going to be doing. So again, it's going to ideally this could be in multiple stages, but to make it simple, I'm running all these commands in one stage. Sudo ECS update, sudo ECS update, update service. update service dash dash. If you see, you can always refer to that, all the options we give it double dash. Update cluster, create cluster. Yeah, actually, in fact, we could have created the original cluster using the create cluster commands. So here we need to give the cluster name. Cluster, we need to specify cluster update service cell USTR cluster name is if you go to ECS clusters PyApp C, and now dash service name dash service. Again, we can copy the service from here. Under this, if you see the PyApp dash service, PyApp dash serverless service, PyApp dash service, and I think now there's one more thing I need to specify on that script. We need to force, if you see that, we need to force deployment, force new deployment dash force new dash deploy deployment. Okay, and I think force new deployment. Okay, this is it. So sudo, it should be AWS ECS. These are all AWS commands. Sudo AWS ECS update service dash cluster. This is the cluster name. Dash service. This is a service name, and we have to force new deployment. Okay, and this is it. This is going to deploy the image. This will force the ECS to use the updated image from the cluster. This is it. So now I've updated the script. I can run. I think there is one error. I can easily find out by running it, or I can also configure and look here. CD, I guess it should be under, all this should be under the codes here. Okay, so we're going to run all the commands. Okay, build now. So it's running. Okay. The pipeline has failed. I'm going to look into why it failed. If we look at the console output now, where did it fail? Okay, now it says sudo docker build -t. Okay, now what this means, sudo docker build -t, it's failing when it's trying to create, when it's trying to build an image. So it's basically an access issue. I'm going to fix this access issue and it should work. If you see, it says sudo docker build -t. That's the command that failed. So so when Jenkins runs the pipeline, the default user is Jenkins. and Jenkins is trying to run this command. Jenkins goes in and runs the sudo docker build -t pyapp dot. So it's not able to run the sudo. User Jenkins is not able to run the sudo. So that means I have to enable user Jenkins to be able to run sudo command. So I'm going to do that now. So now I'm going to grant sudo access to user Jenkins. Sudo users are configured in file called sudoers. It's located under root etc. So we need to edit that file. So it's located in etc. The file name is called sudoers. So now it opens the sudoers file. Here we have to add user Jenkins. So I'm just going to add user Jenkins here, JNK Jenkins, and similar to all other entries, I'm going to make it all. So we need a passwordless access. So I need to specify that here. It's specified with this command and no passwd colon all. So this will fix our access issues. So it's user Jenkins all equal to all, and so it's a read-only file, but I'm a root user, so I can still override it with the exclamation mark WQ. So it's updated. If you do more of the same file, there is the new entry for Jenkins. So this will allow Jenkins to do the sudo. I'm going to rerun the pipeline now and see if that fixes the problem. Okay, it failed again. I believe this might be some other error. So yeah, it seems now now it was able to build the image. So it goes there. So if you it failed last time, it was not able to build the image. Now it's able to build the image and successfully build the image. Sudo docker login. Now again, now it failed because the AWS credentials are not available for this user, sudo AWS ECR. So we would need to configure the credentials for user Jenkins on the machine. So I'm going to do that now. In order to configure AWS credentials for Jenkins, I need to switch user to Jenkins. As of now, I'm root user. I'm going to switch user to Jenkins. Now, this may take me to, okay, now I can run the AWS configure. This will, give keys to the Jenkins user when it tries to connect to the AWS services. So we will be using the same set of keys that we had downloaded. So the AWS key is this. This is the AWS key. This is the secret key. Okay. The region is US East 1. If there's any doubt, you can get it from the AWS console, and the standard format is JSON. Okay, now the keys have been configured, and now that should fix the other issue. And now, if I run this now, it should be able to find the credentials and be able to log into the ECR repository. Build now. It's still running. It failed. I believe it's some other error now. So now it's login succeeded. Now it was able to log into the ECR repository, and it's okay. I think this should be in case sensitive. This should be lowercase. So I'm going to configure the credentials again and specify that output type as JSON in lowercase. I'm going to be running the same command again, and the keys are the same. Okay, the region is the default same. Here I'm going to do JSON. Okay, that's good. Now let's try running this again. It's running. Okay, it succeeded now. We can still look at the console output and ensure all the commands are run fine. So now if you see this console output, it's downloading the repository from this GitHub. And then, here for the pipeline, I'm changing directory to the work directory where the files have been downloaded, including the Docker file. And this command builds the image, and this command logs into ECR repository. And then, this command is used to get a token, and this command tags the image, and finally this command pushes the image to the ECR repository. And here we run the we run the sudo ECS update service to force the cluster to use the updated image. Now if we go into the AWS console again and go to the clusters, we can go to the ECR repository. And if you see the images, here you can see it's been updated recently. And let's click on the image. And basically, whenever we update the latest image, the old version is still there, but it gets untagged, and the new the tag is carried on to the latest version. So now it's been updated. Now part of the pipeline has been automated. So now, whenever we trigger the pipeline, it's going to pull the code from here, build the image on this machine, push the image to ECR, and force the ECS. Now I'm going to, further do the further automation. So whenever there is, I'm going to configure the pipeline to detect any changes in the GitHub repository and run it. And anytime a developer pushes code changes, it's going to automatically trigger the pipeline. Originally, I created the app in a developer Ubuntu machine. Now I'm going to download the repository onto my laptop and apply some code changes and push it to the GitHub. so that it will automatically pick up the changes and run it. Before that, I'm going to reconfigure the Jenkins pipeline to detect changes on the Git repository. So if we go to Jenkins, yeah, Jenkins pipeline, configure. In here, we need to, there is inside this configure pipeline, there is build triggers. Here we need to specify GitHub hook trigger for Git SCM polling. So we need to choose this option here. This will automatically detect any changes we apply to that the GitHub. I checked that box GitHub hook trigger for Git SCM polling, and here you can see more information of that. Okay. When Jenkins receives a GitHub push hook, GitHub plugin checks to see whether the hook came from GitHub repository, which matches the GitHub repository defined in SCM Git section. So we have actually defined the SCM Git section here. Uh, so now after choosing this, there is a configuration that we have to that I have to update on the GitHub. So I'm going to GitHub, and in here we have to go to settings, and inside the settings there is webhooks. This is kind of a API call, so that we have to ensure any changes in the Git repository, it's going to push to Jenkins server. So we need to create a webhook here that will enable that push. Add webhook, and for the payload URL, we need to use the the URL for the Jenkins for the Jenkins machine, which is this. I'm going to copy this, and since I'm using EC2 instances, this could change if I stop and restart the machine, but it's going to be this the IP address colon 8080, the port on which Jenkins runs. And for the we need to add the parameter as GitHub webhook here, GitHub webhook, EBHOOK. This is going to make an API call. GitHub webhook. Okay. So here I'm going to choose application JSON as the content type, and just the push event, any changes it's going to push. Okay. I think that's all we need to do here. Add webhook. Now the webhook has been added so that any changes in this repository is going to be pushed to the Jenkins server. And from the Jenkins side, I have chosen this GitHub hook trigger for Git SCM polling. So any changes, it's going to detect that and apply. So we are all set. The pipeline is totally automated. It's going to detect any changes on the GitHub and run the pipeline. So now I'm going to apply some changes. We can test this directly, like we can go to the GitHub and PyApp and Docker. Here, my inside, I can actually edit this here. I'll put Jenkins. Let's make this a small spell. Oh, I need to edit. Ideally, this is not what people do, but for test purpose, I'm going to edit Jenkins, and I'm fixing a typo here. I can commit changes directly to main branch. So it's going to fix typo on Jenkins. Okay, I'm going to commit directly to main branch, and that's going to trigger a pipeline. If everything is, it's running. Actually, there is the build running, so I think the trigger is working. Oh, no, I might. Okay, I think I ran it twice. This is based on the commit. Okay, so let's see. We can go to that the ECS and see if it's gotten applied there. This is the ECS domain name. Copy it, paste it here. :5000. It may take a second or two. There's a bit of latency, but until then we can check if check the Jenkins console output to ensure that it ran as we expected it. Console output started by user Raj. Okay, I think I might have ran it again. So let me go back, and I'll see this pipeline 6 console output. Okay, this seems to have run fine. Login succeeded. Yeah, if everything ran fine, they should have been updated. So now we see the Jenkins. That's the typo. That should have been fixed. Let me refresh this page and see if it's actually fixed. Yeah, it's fixed now. So basically the pipeline is working. I applied a change from the GitHub here. The pipeline triggered automatically and got updated on the ECS cluster. So the actual pipeline build is complete. So it's completely automated. This all that's needed. But I'm going to add one more step where I'm going to simulate a developer using this repository. So I'm going to run from my local machine. This is my local machine. I'll go to the command line, and here I'm going to cd documents. I'm going to make a directory here for app. I'm going to create the new directory, dploy app deployment. Now on my machine, I already have the Git. So if you see, there is a Git. Now I'm going to clone the repository. This is what a developer usually does. He clones the repository that's there and applies any changes. So I'm going to simulate the same. So git clone. And all I need to do is get the go to my repository, and then inside the code there is this URL. Copy that URL. So if I do that, it's cloning the repository to The clone failed because this is a private repository. So I have to use my username and password. So the syntax, the format for that is, git clone. I just googled it, and it looks like I have to specify the username and password. I'm going to do that now. So here I'm going to use my username password. Username is Raj 34ABCD. The password is not exactly the password. It's the personal access token that I generated previously. So I'm going to access my personal access token and copy paste my personal access token here. Okay, the personal access token is copied and pasted, and here this should be my GitHub URL at HTTPS. That's my GitHub URL. Yeah, it starts with git clone HTTPS, and here it's not the whole URL. It's just this part from get fast.get, and here we don't need this HTTPS here. It's just at github.com. Okay, that's it. So this should work. Git app flask app. Okay, now it's cloning the repository. If I list out, you can see there is a new directory created. This is the PyApp Flask, PyApp flask flask. Oh, it should be inside app. Yeah, it created a PyApp Flask. Here we have all the files that we need. I'm going to edit this file app.py. Actually, see users documents. This is on my laptop. See users documents. So I'm going to edit this app.py application file, and see my first Jenkins CI serverless deployment updated from laptop, updated from Windows laptop. Originally, the first app was deployed from EC to Ubuntu machine. Now I'm going to be updating this file, and I'll push this to the GitHub repository, and let's see, the pipeline will get triggered. I just want to show how it's going to get applied on the ECS. Now I have applied the change here on my laptop, and here all that I have to do is now the file has changed. I'm going to do git add dot so this is going to add the file changes to the git queue, and if I do git status, it's going to show me what's changed. This file app.py has been changed. I'm going to commit this change -m app updated, colon. So the commit has been done. I can check the git status again. So it's all committed now. You can see it's saying all we have to do is git push to publish the commits to the main repository. So now I'm going to push this to the remote repository. Before I can push, I need to add remote repository. I can directly push because since I cloned it, it should work. Git push. Now I'm going to push its git push origin. Since we have cloned from the remote repository, that will be the origin, and the branch is main. There is if we look at the GitHub, we are using the main branch, so I'm going to updating the main branch. Okay, now it's pushed to that repository. Now that file has changed. So from my laptop, I pushed that file changes to the in here. Now that I have pushed the code to the repository, the remote repository, it should trigger the pipeline and deploy the changes to the ECS cluster. Everything is automated. So going back to that EC, I can first check here on the, or maybe I can directly check on the. If you see, this is what it was, my first Jenkins ECR serverless ECS deployment. If now it should have been refreshed, and now if you see, it's been updated. My first Jenkins ECR serverless ECS deployment updated from Windows laptop. So basically, this is how the whole pipeline works. It's totally automated. Just to look at the overall picture, this is how the pipeline. Initially, I developed the application in Ubuntu machine, pushed to the Git repository, and I created just Jenkins pipeline that pulls the code from here, the GitHub, and then creates an image, pushes the image to the ECR, and then Jenkins also updates the ECS cluster here. The whole thing is automated now. Now I have simulated the whole process like a developer using from the from his machine. So I pull the code from the GitHub onto my laptop, updated the code, pushed it to the GitHub. The automated pipeline took care of rest of the things. It deployed the code to the ECS cluster, and so this is already reflected here. So that's all. And the ECR, there is a minimal charge for creating ECS clusters, I believe. So you might want to tear down any ECS clusters you have created. And even though you can remove the ECR repository. So that's all, guys. Take care. Bye.